So hi guys, welcome again to another wonderful video of mine. Doppler effect is what we are doing today. I'm sorry my voice is not that loud. Just you have to listen, maybe with earpiece or any other things, as a made of listening tools. So I'll be doing the concept of Doppler effect, and I'll do that in supposedly 35 minutes, all things being equal. So I will first of all take you through the understanding of the effect, and I will talk also about the mathematical interpretation of the effect. Then we do exam type questions the way I usually do, 2 questions. Then you answer the third. My admin is not on seat, I'm the only one administrating myself, so I will be doing that. But if I need calculator, I have somebody here that will actually help me press some stuff on our phone. So we start with Doppler effect. Now the Doppler effect actually came about, we are studying some in-depth concept about waves and transmission or propagation of waves. Now Doppler effect is basically also on sound wave. This is just a process that explains the change in frequency of sound as it moves from one point to another. Imagine a siren is being heard from a far distance. As the siren is coming closer to you, what you expect is a louder sound or an increase in frequency of sound. So what constitutes this change in frequency of sound? When the body is approaching or receding, that is going away from you, is what we want to study. And this was first studied by a man called Doppler in 1921. Now, for better understanding of this, stay and watch this video to the end. And if you're new to this channel, you can consider subscribing to the channel. So let's write the language form of Doppler effect so that we can actually understand it mathematically as well. About the language form, we can write. Now, according to Doppler, we were told in junior classes that due to relative motion, permit my handwriting, due to relative motion, not now, between an observer and a source. The apparent change in the frequency. The apparent change in frequency of sound waves as it moves from one point to another. So that is what we call Doppler effect. So what constitutes the change in frequency of sound as it moves from one point to another is known as relative motion. So as body approaches and recedes from you, you tend to hear the change in frequency of sound. This is what we call Doppler effect. So please note that a very good illustration, we can give examples, or the definition without example is rubbish. And talk about siren observed, or the sound of siren observed by a listener. So these are simple examples. So to understand it conceptually, or understanding it well, we are going to talk well on it as we move to the next slide, which is going to tell us a good example and how to illustrate or demonstrate this mathematically. So you can always consider an observer to be at one point, and wave is always propagated in terms of this. You know what I mean by movement of waves. Sound wave, for example, if you talk about movement of wave, we use a particular formula which I believe you've studied in your junior classes, that is V is equals to F lambda. So as the wave is going, let's say the observer, this is the source, the observer is there, so it will now continue to move until it reaches this gap. So the movement in the frequency and the analysis are going to be studied mathematically now, and let us see the mathematical aspect of this. Now, to understand the mathematical aspect, let's proceed to the next page. Yeah, thank you very much. Now, this is the next page we have before us. About this, for you guys to see well. You want something you cannot see. I hope it is not cutting now. I just hope. So now, here we are. Yes. Now, to understand the mathematical aspect of Doppler effect, we are going to consider two bodies, like the source. We are going to consider the situation of the source producing the sound. We are also going to consider the observer noticing the sound. Just relax, it's not going to be difficult. So in doing that, I'm going to bring you back to some important formula which I suppose you might have studied in your junior classes. That is the concept of formula concept of wave. I hope students still remember the concept of formula that said that V is equals to F lambda, whereby F is the frequency, which is defined as the number of oscillation that is being produced per second. So the frequency of sound, the way we measure it, I hope you have studied that, and if not, you can pay attention to the way I will do this. So now, if sound is being propagated, there are two bodies, the source. I'll call this the source of the sound. I'll call this one the observer. So just for understanding's sake, and I think I need to rule so that I'll be able to make it self-explanatory. Okay, fine. So we can move. So now from here, what we need to understand here is that when the wave is generated, the wave is moving at its constant speed. So there are some things I'm going to take as constant. Let me write them out as well for understanding's sake. The first thing I'm going to take as constant, which you keep in mind, is I'm going to use parameters like velocity of sound. Velocity of sound, we've studied that sound is an what? Adiabatic process. Now will be taken as Vs. Let me just write it as Vs for understanding's sake. Now velocity of observer of source. Velocity of source. Let me take speed of sound as ordinary V. Please note this. Velocity of source, because I want to use Vs for that. I'll take it as Vs. And velocity of observer. We take that as V naught. So let's just take that. So, and we are going to use basically the concept of V equals to F lambda to explain all what is needed on this one. Talking about different situations when the source is moving, when the observer is moving, when the source is at rest, and the generalized formula that is being used. Now I told you the mathematical aspect will explain better how we come about this formula. So I'll just do maybe two, then I'll use the generalized formula as well. Then by that time we take examples, then you will be able to answer questions on this topic. I'm pretty sure about that. So having said that, so now we are going to consider a situation. Let me take the first one. The source is at rest and observer is moving. So that's the first case I'll quickly take here. Then I'll use the second one to explain the second situation. Then I'll also come back. So if we have that, my dear student, sorry, I just have to come here for you guys to see well. So now, if that is the case, so if we have this now, the source of, so far the source is at rest, observer is the one moving. So we take something, so if this is propagating the sound, we measure sound, let's say it is moving, just giving you, this is what was propagating. Initially, it has distance between successive crests. That is why I say basic knowledge is needed, is what you call wavelength. Apologies, I'm waiting for this to come up. So distance between two successive crests here is the wavelength, initial wavelength here. So far the source is stationary. Velocity of the source, this is the source. I hope I'm not cutting. The source is here and its velocity is constant. Alright, velocity of source is constant. So this is the observer here. Just listen. The observer is here. Now initially the speed is propagated that, I'll just take that at a speed, I'm taking the speed of sound to be v, which is the one that is coming towards this guy. So as it's coming towards this guy, we can just use this relationship to get the initial wavelength. We can say the initial wavelength of this thing will be the initial speed, which is v, divided by the initial frequency I will take as f. That is for this stationary source. So, but as something is moving, propagating, what will be heard by this? Imagine, remember that this observer here is moving. So far the observer is moving, the speed of the observer we are taking as v naught. Just listen, there's nothing difficult in deriving formula. It's moving towards this. Now, the relative speed of the two of them will be what? Because we are talking about 1 second. What will reach this guy in 1 second is what we're talking about. So what will reach this guy in 1 second is just what? The sum total, because I'm moving towards you, you're also moving towards me. I take 2 steps towards you, you take 2 steps towards me. The total number of steps we have taken is 2 plus 2. I hope you understand that. So in 1 second, frequency is the number of oscillation made per second. So in 1 second, the wavelength we measure in terms of 1 second. So that is why now, the one that will now reach this guy now, I'm just doing an illustration, will now be the sum total of, in 1 second, please, will now be the sum total of V plus V naught. Please note that. So, and if I want to go by V plus V naught meter, that is what we measure, because we are talking about distance, what? Frequency is the number of oscillation made per second. So in 1 second, that is what is coming to that guy. So using the same formula, using the same, this formula I've used, definitely the wavelength that will reach this guy, or we can say the speed, the frequency of this guy. So the frequency, the final frequency, I will call it f dash, that will reach this guy now, because we are saying the apparent change in what? Frequency of sound is what we define as a Doppler effect. So the frequency that will reach this guy will now equals, that is what I write as f time, will now be equals to speed. Now the speed now you guys can see is now v plus the one coming from the speed of sound, and this one that is not stationary plus v naught divided by the wavelength. Now the wavelength we have here is as you can see, the wavelength we have here is divided by lambda. I will substitute. I just want you guys to see. Now here, initially I know that lambda here, v over f is equals to lambda, so which I can also substitute back, or basically I can write the speed of this in terms of new frequency, then substitute back. It depends on the way I want to do this. So now what I've done here is that I make frequency subject formula. Then I know that the new speed that is coming together here will be this one plus this one divided by the what? The wavelength. So now, initially, I know wavelength formula to be equals to V over F. So if I substitute wavelength formula back to be V over F, I'm going to have nothing but, I can say continuation from that side. Then if I continue from this side, from this formula, the final frequency, F dash, will now be equals to, so it will be equals to, you have, look at this guys, it will now be V plus V naught all over, please watch, lambda here is V over F. So divided by V over F. So now I can rearrange my formula, V gets cancelled out, and if you are just a beginner, you are not that strong in mathematics, you can do it one by one. You can say therefore F dash, new frequency, is now equals to V plus V naught divided by, you can see this V over F. Why I'm showing this is because I want you guys to see that there's nothing so difficult in all this. You can cut directly. So when you come here, this one will come up, the other will come down. So you have F dash, watch out, is now equals to V plus V naught. I may not show this one in the next derivation, times F over V. So what we're talking about now is that you have, this is the expression you're going to have, F dash is now equals to, the F is outside, then you have, and see, you have F outside, F is multiplying of F by V. If you want to write V plus V naught, which you can still reduce anyhow you want to reduce it. So this will be the frequency. You can say V divided V, we call V, or if you are the type that you like to solve, LCM is V. So V open bracket, LV whatever. But what I'm trying to let you guys know is that at that particular point in time, the frequency that will be reaching the what? The, what's it called? The observer as it's moving towards the source is going to be that particular formula. So now, if body is what? Why we don't include the part of the observer is because the observer is what? The source. It's because the source is said to be stationary. I hope you guys understand what I've done here. I can even modify this formula and write it in another way, but I think it's best in this format. What I did is initial wavelength, then the final frequency that is coming to the observer. So having done that, I try to make, and I turn this one back to what it was, then do the kind of simple mathematics. Normally, this V can cancel this V. Yes, it is possible if you expand. It's just like saying F over V times V. Everybody knows F over V times F over V times V naught. That is F V naught. So I just want to leave it like this for now. Don't forget, this is for observer, this is for the speed of sound. So that is that. The other relationship I would love to do now is when it is the opposite of what I've done now. When the source is moving and observer is at rest. So if I'm going to do that now, I will have to quickly clean this side of the board, then give you a generalized formula that you guys should keep in mind. So let me quickly do that at this side of the board and let you guys understand the concept. And we just put the formula, the general formula, then we solve some example with respect to that. So let's do the situation whereby our observer is at rest. Observer at rest and source is moving. So that means you are at rest, then the source is coming to you. Definitely. Now, the problem about this case is just not a problem anyway. The whole stuff about this one is just that. I'll be quick about this guy. Sorry, I'm too fast. So the whole stuff about this one is in this case now we need to know initial speed of propagation is always taken to be V. So now the source is going to also have what? Its own speed, Vs, which is going to propagate as well. So the observer is at rest. We don't actually need the observer stuff, but just let us put it. Observer speed is at rest, which is 0. So once we reach the observer, we are going to see. Normally this will propagate. So the initial lambda is the distance between this guy, so which is a wavelength. We've talked about that, initial wavelength. So now, the only thing we just have to keep here is that at a particular point, at a time t seconds, there will be a change. There will be what? This source speed will have reached a particular point. So, and because of that, this initial lambda that we have taken to be constant in this situation will change. So there will be an apparent wavelength between the two. So which we need to know the amount of wavelength that will be transposed or transferred to the second body. That's the only thing you need to keep in mind. And remember, from velocity is distance over time. So if you actually want to get distance is what? Velocity times time. So, and here in this case, we are not doing time, we are doing frequency. So we have to do it in terms of frequency. So if you remember, frequency and time are inversely proportional to each other. These are some stuff. Say F equals to 1 over T, or T is equals to 1 over F. So if I go with distance is equals to velocity times time. So time now, I will just write as this is the speed of the source multiplied by T here is 1 by F. I think it's better in that way. But I've written it like this, 1 by F. So at this particular distance of V equals to 1 over F, there will be a gap here because this particular body, let's say it has reached this point. So the one that will be left over will be the one that will come and meet this other body. Just trying to show you some simple logic about how we do all these things. So all these things are actually very simple. But the only thing you have to keep in mind about them is understanding them, so that when you see questions, you won't have what issues. So by and large, my point is so if this is the speed at this point, so the final wavelength, apparent wavelength, I can call it lambda apparent. It will now be the initial lambda minus, this is speed, distance is lambda here, so that you will get what I'm doing. It should now be minus, this one is V over, that's V taking Vs over the frequency, which you know, I can actually take that frequency to be another thing. So I've done that in terms of frequency and speed. So I think it's now very easy to just go. So the only thing that will reach this guy, because this body is at rest, the only speed that will reach this one is what the only meter we are calculating here is just the speed of sound. So if we want to go by that directly, I can now say, following what we have studied here, our apparent frequency will now be equals to, frequency is equals to only this speed is coming, V over, then the apparent wavelength now is now lambda minus Vs by F. So initially you can write the initial lambda by F and try to get modified formula. And if you want to go by the initial lambda, if you want to go by that, is, you know, initially we always write lambda equals to, you can write it, the initial speed over the initial frequency, which is F. So if you substitute that back to this formula, and say V over F is equal to that lambda, then whatever you are going to have your answer. So what I'm trying to say is that all these modified formulas are different ways of actually deriving formulas for Doppler effect. But the only thing that matters most is that what this particular formula can be modified in different ways. Now, for example, look at what I've done here. And the first example, I'm talking that what the observer is moving towards this side. If the observer is moving towards the other side, if it is not towards this direction, then I can put plus and minus in my formula. So the same thing is applicable to this formula here, because I'm saying this particular source is moving towards this side. If it is moving away, and this will be what? Plus. So the generalized formula is what I think you guys need to keep in mind. And for us to be able to proceed to the next slide, we need to keep the generalized formula down. And that is what I think we all need. But in case you are asked to derive the formula, this is how we come about the formula, and these are the ways in which what we use them to solve what questions, and that is all about it. So to get the generalized formula, we can quickly do that in just 10 seconds. Let's do that in 10 seconds. To do the generalized formula. Okay. The generalized formula, we can combine different situations so that we won't be having issue. So the generalized formula for Doppler effect is now giving us, now the new frequency is F dash, will now be equals to, we can just go that like to be F into bracket V, that's the speed according to what I've been using, V plus or minus, I will explain, plus or minus V naught over V plus or minus Vs. So now, the concept of what I've used here is just the combination of what the two stuff I've done. And actually, I was able to understand as you are moving towards the source, the frequency tends to increase. So because of that, as you are moving towards the observer, you can see direct relationship of the apparent frequency says, as you are moving towards observer, if the direction is moving towards approaching, you are going to use positive. Now, if the source is moving, look at this frequency, new frequency here is the kind of inverse. So if the source is moving in the direction that is moving towards the person that is what observing, here you know what you use because it's an inverse. So if it is moving towards the person, you use minus, because this is an inverse relationship. It is moving away, you use plus. But for this one, if it is moving towards, you use plus. If it is moving away, you use minus. So this application is very, very important, and that is the essence of why we are taking this concept. So this particular one is what we want to study, and this particular formula is what I want you guys to actually write down and keep in mind. So this is just what I am here to do today. So the next thing for me now is just to use this to solve 2 examples. So now it's time for examples. Let's see how can we apply the problem. Fine. So favor, you help me with calculator, please. Now here we just have to start. I'm only doing 2 examples. Like I said, I'm not going to do more than 2. I've promised that. Now look at the first one. Fine. The first one says an automobile moving at 30 meters per second is approaching a factory. The automobile is approaching a factory, so it's going towards the factory. So fine. A factory whistle that has a frequency of 500 hertz. That's the initial frequency. If the speed of sound in air is 340, we can write parameters the way you were taught in the junior classes. Writing parameters down might be helpful sometimes. Apologies. Now, most times it's helpful, not sometimes. So if we go by that, we can say, fine. Parameters given here is nothing but we have important parameters given is moving with the speed of the speed. Automobile is moving. Automobile is moving towards the factory. So automobile is moving towards the factory. So that is the source is moving and is 30 meters per second towards the factory that has a frequency of 500 hertz. So initial frequency, which I write as F from my formula derivation, is 500 hertz, Hz. If the speed of sound, I wrote speed of sound as V, is 340, I'm going to manage up, 340 meters per second. What is the apparent frequency? That is the new frequency, and that is Doppler effect. So F dash, you don't know, I write down as question mark. This means question mark, not 7. So what frequency of the whistle is as when the driver approaches, when the body approach the factory. Then the second one says when it recedes. When it approaches, and when we know the formula is F dash is equals to, so that means the factory is stationary. So please note that F dash equals to F into bracket V, is it plus or minus? Now let us just know V plus V naught. So now why am I going for V plus V naught? Well, even my V naught here is kind of V naught over V minus Vs. Now the question is, why am I going for this formula? I'm going for this V plus V naught because I was told here that this thing is moving towards the factory, and the factory, we are not giving the speed of the factory, we are only giving the automobile, which is the car that is moving. So the source is moving. So when I told you when the source is moving, because this is inverse relationship, it will be what? It will be what? It must be what? It must be negative. But if it is going away, it must be what? Positive. So another thing we need to understand is to know if, in this case, automobile is moving. So automobile is moving, is approaching a factory whistle. Wow. Look at the English. Now I will have screwed that. It's not a factory, but a factory. Look at this, a factory whistle. So this is the source. So this is the observer. So I'm actually interpreting as that is the source, that is the observer. So that means here the observer is moving towards what? Towards the source. So observer is moving towards source. When observer, this will be positive, no doubt. Then observer is moving towards source. That means source is stationary. Velocity of source is stationary, and that is equals to 0. So please be careful about that. Observer is moving towards the factory, then this is positive. So when it is now receding, the formula will change to negative. So now we can just do that. F dash will now be equals to, now this is where F is 500. Then we open the bracket. Then we have V, speed of sound is 30. No, 340. As plus V naught is V naught was for that is the source. I told you. It's 30 divided by, and this one is 340 minus 0. So now we can finish this. So F dash will now be equals to directly 500 times 370 all over 349. This is where I need calculator just to get the answer directly. 500 times 370 divided by 340. I just need final answer. So I'm waiting for my admin for today to help me out do this one. 500 times 370 divided by 340 will be the right answer for this. 544.117. 544.117. So the 544.
By approximity, that will be 544.118.
Okay, 544.118. So 544.118. So 544.12. 11812 meters per second. So that's what we have. So if you have any other answer when you press one calculator, you can drop it. Excuse me, down to the comment section. So be careful. Like I said, this is observer is moving towards the source. The source is the what? The one that is producing the sound. So please always keep that. Then the second one says when it recedes. Now the only difference between when it recedes. Now when it recedes, I told you when it recedes, the sign here will change for this thing. So it will just be the opposite of what I've done. Then I won't use a new page. I would rather manage this page that I have. So it will just be the opposite of the formula. Initial one is 500. An open bracket. This time it will now be 340 minus 30 over. It will still the same thing down. 340. So directly, if you can do this for me again, 500 times this is 310. 500 times 310, answer divided by 340. So that's that for the second one. So I will know I've actually done the two. So help me out, please. 500 times 310. 500 times 310 divided by 340.
455.882.
Okay. 500 times 310 divided by 340. 455.882. Okay, 88 meters per second. So that's that. Let's just hang it there. And that is how to solve questions on Doppler effect. Just be careful about the position of the body when you know the generalized formula instead of wasting your time on one or two things. So the last one, which I will do for today, this is the last one. As usual, I will do two examples. So let's look into this. A car is moving. The car is moving with a speed of 20 meters per second with its horn blowing. So that is the one producing the sound. So that is not the observer, but that is the source. So please always keep that in mind. Source and the other guy is very important if you are doing this topic. If you don't know how to get the source and the one that is not the source, then you are going to have a lot of issues, which I don't want you guys to have. So the source is moving. You can see 20 meters per second. While its one is blowing at a frequency, initial frequency, I call that F, 1200 Hz. Now it's chasing another car going at 15 meters. That is chasing the car. I said this is now. This one is also going away. So as it's trying to move towards, the source is moving towards. Observer is now moving away. You know what that means. So observer V0 is now equals to 15 meters per second. What is the apparent change in frequency? That is F dash, the way I love calling it. Is question mark, that's question. Take the speed of sound to be Vs is what we are giving speed of sound 340 meters per second. So I think this one is simple. So that means they are looking for it at what it is receding. So because the observer is moving, the source is moving, we know the formula F dash will now be equals to, it will be equals to F open bracket, command my hand. So it will be equals to F open bracket, we have V. Now in this case, the observer is moving away. So it will be V minus V0 all over, then here will be V, because this one is moving close, the source is moving close, V plus Vs. So we substitute parameter and we're going to get the answer. When we substitute parameter, F is 1, 2, I think this one will put the answer in kilowatts because the values are big, 1200, open bracket, V here is speed of sound, which I call V. Speed of sound is my V. Please note that that's 340 minus V naught is 15. Why am I subtracting? Because this one is moving away. So divided by V is 340 plus VS is 20. So what my dear admin that is helping me now will do for me is that just help me press this on calculator. 1 2 multiply by, that's 325 divided by 360. So that's 1200. 1083.
Yes.
Please help me confirm again.
Yes.
1083.33HZ. So please note that HZ should be, it is frequency. So maybe the previous one we are writing meters per second. So the answer should be in HZ. Apologies. So please note that not we are calculating frequency. So sometimes it happens. SI unit of frequency is not that. So that is that about that, guys. I'll be stopping here, but before I go, I always love to give you one to attempt. The final one here is the one you are going to attempt, and you can drop the answers under the comment section to see if you guys actually understand what we've talked about today. So guys, I will see you guys soon in my future video. Don't forget to subscribe, like, and share this content. See you soon. Bye.